Welcome back, friends. Today we are going to solve LeetCode problem 35, search insert position. This problem is related to binary search, and I just want to mention that binary search related problems are in most of the interviews they are very popular problems. They are getting asked in most of the interviews. There are different variations of binary search problems. This is kind of a little bit of a variation. I will explain why it's a variation and how we can use the binary search in the solution. uh, as you might know, I often create lead code solution videos using Java, as well as interview helpful material in Java J2E technologies, and I already have created a good playlist there. Check it out. It has a playlist for lead code solutions, as well as problem solving using computer science methodology like DFS, BFS, binary search, dynamic programming, linked list. So take a look. It's a lot of good material, so please subscribe to the channel. Subscription is really helpful, so please subscribe. So let's take a look at the problem now. So given a sorted array of distinct integers and a target value, return the index of target is found. If not, return the index where it would be if it were inserted in order. You must write algorithm with log of n time complexity, right? Runtime complexity should be order of log of n. So as you might be already aware of, binary search is the way when we want order of log of n time complexity, right? We are going to solve this problem with using binary search. So let's first take a look of the problem here, and I will explain how we will be using binary search. We have, let's say we are given this array actually, and now we are given a target position. Target element is equal to 3, let's say, right? Target is 3 that we are trying to find in the array. These are the indexes, right? So this is the indexes in the array. So as you can see, one is at index 0, 3 is at index 1, like that. So as how binary search work is, in the beginning we start with left is equal to, this is left, so left is 0, and right pointer will be at the end of the array. So right is here, which is 6, and left is here, which is 0. So right is equal to 6, and we always keep calculating the middle element to decide where to find the target element, right? So middle element, we will use this formula. So this is a way you can find the middle element of the array, right? Left plus right divided by 2. So as you can see now here, left is 0, right is 6, so left plus right is 6 divided by 2 is equal to 3. So our middle element here, middle is equal to 3, right? Middle is equal to 3. So we will go and we will search here. Let's say this one, right? So middle is 3 now, right? So we are here, so we found 7, right? At the middle element 7. So since 7 is greater than 3, right? 7 is greater than 3, so we know that the element should be on the left side of the 7, right? Because it's a sorted array. So now if we have to find the element, this is the side we should look. Actually, this is the side, right? Left side basically. So this is 7, so 7 is greater than 3. So what we will do is we will update our right side to the middle minus 1. So right is 6 now, so right will become 3 minus 1, which is 2. So right becomes 2 now. Left is still 0, left is 0, right is 2. So now we will again calculate middle, right? So middle is left plus right divided by 2. So 0 plus 2 divided by 2 is 1, right? So middle now becomes 1. So middle is 1. So we go here at this 1 position, and we again search what is at 1 position. So we find 3 here. So we will keep comparing with our target. So our target and these 3, they are matching, right? So we will just return 1 in that case, because 1 is the position of the element where the element is present. So we will return 1, right? 1 is our answer. So while we are doing this example, I will show you how it's like executing the test case also at the same time, and we will keep like looking code as well as example, so you will also know better. So this is the example that we have been discussing, right? 13579. So now we are trying to search for element 3, right? So we will just pass 3 here as a target, and we will run our code. So I just put a system out here to show you how the code works, right? So now as you can see, 0 and 6 is the I and j, which is left and right. Now middle we calculate 3. After that we go to like we go to left side. So now I is left is 0, right is 2, and middle is 1, and we found 1 at 3 at one position, so we just return 1 here, right? 1 1. So that is the thing. Like now we will take another test case where the element is not present in the array, and in that case we have to return the index where it should be. Basically, if we, as you can read here, if not, return index where it would be if it were inserted in order. For example, now we will search for 2, right? 2. So this is our original array, 1 3 5 7 9 11 13. So if we want to insert 2, it should be insert at this position, right? It should be insert at the position where 3 is. So that's how we should get the answer. So for example, if we run the code here, then we should get the answer as 1, right? So now let's look into this another scenario here. So I'll just quickly remove these things so I can again explain you with the other example. So now our target is, instead of 3, our target is now, let's say 2, right? 2. So we will again start. So we have left. So we have left, right? And then which is 0 in the beginning. We have right. So right is equal to 6 because 6 is the length of the array. So first thing we will do is we will calculate middle, right? Middle element. So middle is, as you know, middle is 3, right? 6 divided by 2 is 3. So we go here at this position 3 and we find 7. So 7 is greater than 2. 7 is greater than 2. 2 is our element that we are searching. So we will again, left is still 0. Now we will reduce the right, right will be middle minus 1, so right will become 2. So as you can see, the right pointer will come here now. So this is our right, this is our left, right? So 0 plus 2. Now again we will calculate middle. So middle will come as 1, right? 1. So we will take a look at 1, and the position which is 1 has is 3, right? 3. So again 3 is greater than 2. So now what we will do is we will again calculate the middle, right? Left plus right divided by 2. So 2 divided by 2 is 1. And since 3 is greater than 2, we will try to go left side, right? So as you can see, left is now 0 and right we will decrease by 1 basically. So right will decrease by 1. It is 1. So now it will be again 0, right? 0 0. So same thing I'll show you here. So as you can see here, 0 6 3 0 2 1 and 0 0 0. This is where we are now, like 0 0 0, right? This is where we are, 0 0. And now if you calculate middle, then 0 plus 0 divided by 2 is again 0. So we are at this position and we are finding 1. So 1 is less than 2, right? 1 is less than 2. So now we will try to go on to the right side. As of now we were trying to go left, but now since 1 is less than the target value, we will try to go on the right side now. So when we are going onto the right side, we always increase the left value by 1, right? Left value by 1 in the sense is middle plus 1 becomes middle plus 1. So left becomes 1, right is still 0, right? So left is now greater than right, right? So as you can see here also, left becomes 1, right is still 0. So left is greater than right. So now we have a condition here. If left is greater than right, we will just return left, right? So left we will return. So we will return 1 in this case. So 1 is our answer. So 1 is our position where we should insert 2, right? So we can insert 2 here. We can insert 2 at the position of 3. So that is the correct position, right? So array will still remain sorted. So this is the way we can, find out the correct position if the element is not present in the array, right? So I will show you the code implementation now. So we just have, like, directly we have one function, private function. It is a binary search. It takes the array, it takes left pointer 0, and it takes nums dot length -1, means it takes the last index of the array, and it takes the target, right? So this is the signature. So I is left and j is right basically here. And we always first calculate middle element by using left plus right, I plus j divided by 2. This is the system out I was just showing you. And then first thing we will do is we will check if I is greater than j, right? In this case, as you see here, the last time this I becomes 1 and I becomes 1 and j is still 0, so I is greater than j. So in that case, or m is greater than array dot length -1, means if it is going outside here, like let's say we have we want to we are searching for, let's say, element 20 here, right? So now in that case, here the element 20 will go at the out of the boundary here, right? So for that case we have to check here if this m that we are calculating, it is going out of the boundary of the array, then we will have to return I, right? So for example, if it is 20, then we will have to return the position as I, means 6 basically, right? So that's what we are doing here. And then we will always, like, after this condition is checked, we will check if the middle element, that middle element is the key that we are looking for, right? Target. If it is the key, then we will just return middle, like m as the index that we want to return. Now if the middle element of the array, if it is greater than the key, which means that we have to go left side, right? Because the element we are looking at the middle is more, like, bigger than the key, so we have to look into the left side. So that's what we are doing here. Here we will just keep left as it is, and we will just reduce right is equal to a middle -1. So we are going on the left side. On the other case where middle element is less than the key, where we are looking, like, middle element we are looking at, if it is smaller than the key that we are trying to find, then we have to go right side, right? Because it's a sorted array. So that's what we are doing here. So in that case, we will just change our left to middle +1 and keep our right as it is, and just pass key here. So this one is return -1 is because the function will require something to return. We put -1 here, but this is the way it will work basically. So now, apart from this, I will show you one other example where we are trying to find 20, right? So this is the one that we did not try yet. So as you can see, I is now 7, right? 7, and m is 6, so it will return 7 basically, right? So as you can see, 13 is at the end position, so 20 should be here, right? At the 7th position 20 should go basically. 20 should be here at the 7th position. So that's what it will tell us, right? So it's working correct. So let's just, I already showed you couple of examples here, so let's just take this example as well as the one that is actually when the element is present. So let's do one quick run and all the cases should be accepted. So yeah, so everything is accepted. We will just remove our system out. This is not required. This is only for a demonstration purpose, right? So yeah, everything is working fine. We are getting the correct result here, 117, right? So we are getting correct result for 11 and 7 for 20. So we will just submit this now. So our code is running 100% 0 ms faster, so which is pretty good. So it is also accepted. It's a log of n time, right? Because it's a binary search. So this is obviously it is a lot better than the linear search. When we are doing linear search, we have to traverse all the array elements, and it becomes order of n, right? So it is expensive. So for these kind of operations, binary search is the best way. I'm going to put this solution in my GitHub account. Take a look from there. Try to play with little bit different arrays and different values. You will then understand more about the binary search. But I already explained you in detail, I think, how binary search work here. So yeah, I often create these lead code solutions in Java, and I also create interview related videos for Java J2E, where also try to focus what are important questions and what are getting asked in the interviews generally, and how to prepare. So please subscribe to the channel. Subscription is really important and helpful for the channel to grow. Thanks for watching this video.